Whoa! Okay, that's cool.
Learning with Papa Sean and Ailani.
And Mommy too.
Ailani and I have been in our computer lab working on a new theorem. We are trying to find the answer to a question. That question is, why do you fart when you eat beans? Because I tend to fart excessively when I eat beans. And you haven't even heard about Ailani farting.
Shut your mouth.
It's like flowers escaping from flower hole. Oh, negative. All right. Oh no! What was that, Ailani?
No, the robot.
Oh no, our sweet little robot has been destroyed. And look at the TV. And there's fire. Well, we gotta put the fire out. Do you have a fire extinguisher?
Here.
Here you go, you put it out. Now we get to travel around the world to find some interesting people who might be able to help us figure out what's going on with science.
Let's go to the giant computer board, Dad.
Let's go and check out the map.
We have a bunch of different destinations that we can go to find people who can teach us how to find and bring back science.
Yes.
Now, let's go to our first location, shall we?
3, 2, 1.
Whoa! We are in the Vietnamese rainforest.
Wow.
And we are here to meet a very special scientist. His name is
Chồng Hiếu.
Hugh?
Chồng Hiếu.
Maybe Chồng Hugh, but that's Hugh.
No,
There he is
Chồng
right
Hiếu.
there. Hello,
Right
Hugh.
there.
Nice to meet
Hello,
you.
Đại Chồng Hiếu.
Now, Hugh is a special scientist. Whoa! What's that?
It's a monkey.
It is a monkey. Now, this is a special type of a monkey called a langur. And in Vietnam, we have lots of different langurs like this guy. Now, Hugh has been studying the langurs here in Vietnam. We actually have a really cool scientist here with us to help us learn about the scientific method. His name is Maynard. Now, Nee, would you like to ask Maynard our first question?
Why do scientists start by observing things?
That's a great question. Well, everybody makes observations, and you don't even have to be a scientist to make observations. You right now, your dad, everybody that you're around, we make observations every single day. When you wake up, you look around and you see if the sun is shining, you see if your bed happens to be wet, you see if there's water on the ground, you happen to see if there's, I don't know, a spider on the wall. You're making observations by seeing things around you every day. And so scientists are just like everyday people. We make observations, we look around, we see how things are functioning. And from there, that's how we understand how certain things work. That's how we start to ask questions. That's why we start to want to know why. So if we see something and it seems funny, or it seems interesting, or it seems like it shouldn't happen or it shouldn't belong, then we start asking more questions. And then that leads us down the whole scientific method of being able to experiment and then being able to conduct tests and then examine some more, right? And then make further observations. So observations are the beginning of us understanding how and why things work.
Now, science starts by observing things. Now here, we can observe lots of different things. As we observe these langurs,
We can observe the movement.
yeah, langurs swing and jump between trees.
Babies cling to mothers as they move.
Just kind of like this. Hi, Mommy. Color.
Some langurs have gray or golden fur.
Yeah, and some baby langurs are bright orange.
Sound.
Yeah, some of them make soft whooping calls like whoop, 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 whoop.
Some of them make loud warning barks like
And sometimes we can hear the leaves rustling as they move. We can also observe their behavior.
they groom each other and clean their fur. Ah! Stop eating me.
I'm eating all the insects in your hair.
Oh my god, I'm so clean.
Just
They
like a
know
langur.
insects.
We also can see their behavior. They eat leaves and fruit, and young langurs play and chase each other. We can observe their habitat,
They live high up in the trees.
not on the ground.
The forest is full of vines, big trees, and flowers.
These are all things that we can observe, which is step one of the scientific method. Now on to our next destination, Nee.
We don't.
Wow. I caught her. She was kind of stuck in the whirlwind. We are now in the African savannah. We are here to learn from another scientist named Nasambu.
Hi.
Hello, Nasambu. Now, Nasambu is actually studying something really cool. Do you see those animals right there?
I do.
Those are elk.
Elk. Wait a minute.
Sorry, hang on. Those are wildebeest. Sorry, I was wrong. They're not elk. Elk are not in Africa. Those are wildebeest. Now, do you know something that wildebeest do that's really interesting?
Yeah, Dad, they migrate.
That's right. They migrate long distances. Now, a migration is when animals travel from one location to another.
Why is asking questions so important?
I think this is really important to ask Maynard. Now, we need to ask some questions. Let's see what he has to say.
That is a great question as well, too. Well, you're asking questions right now, and the reason you're asking questions is because you want some answers. You want to know why. And a lot of times we don't have a certain expertise, right? Sometimes you have to go to school and get training, or you have to practice something. I happen to love wrestling. I'm a big wrestling fan, right? But I can't just all of a sudden go and start wrestling. I got to start asking questions. How do you do this move? How does this work? How do you now engage with another wrestler? You have to ask questions in order to understand exactly what you're going to start working on or start studying or start participating in. So you always start by asking questions so you have a better understanding. And it goes hand in hand with what you stated earlier about observations. When you make an observation and you see something interesting, then you ask a question. Why did that happen? How did that work? And then that leads you down this further journey of now exploring and being able to experiment so that we could ultimately find some answers.
That's really a great information from Maynard. Now, what are some questions that we could ask?
Why do wildebeest travel so far every year?
That's a great question. I want to ask the question, what makes them all move at the same time?
How do they know which way to go?
Do they ever get lost?
No idea. Why do they cross dangerous rivers with crocodiles?
What happens if a wildebeest gets left behind? These are all really good questions. Now, thank you, Nasambu, for teaching us some about wildebeest. I think we need to go to our next location, shall we?
He's the one.
Whoa! Feeling a little sick there. Where are we at now? Oh, Ailani's still sick. We are in the Amazon rainforest, and we have our next scientist right there. What's her name?
Hello, Anna.
Her name is Anna. Now, Anna is studying all about the scientific method as well. And she is here in the Amazon trying to study about things and whether they can sink or
Float.
float. Sink or float.
Sink, float.
Which is awesome. Now, I think we need to call Maynard before we do any more scientific experimentation. Hey, Maynard, we have a question for you.
How do scientists make smart guesses?
Yeah, scientists have to make smart guesses. Let's ask Maynard how and why.
Well, I don't know if every single guess you can say is smart, but there's no wrong guesses at the end of the day. We make guesses because that leads us down this further examination of wanting to get answers. Guesses are very similar to questions, and they tie in with our observations as well. These are all steps of the scientific method, which is a great time to actually talk about what the scientific method is. When you want to be able to solve something, when you want to be able to solve a problem, you go down this whole pathway of observations, of experiments, of questions, of testing and analyzing, and then coming to a conclusion. This is how we're able to make proper demonstrations and gain a better understanding of how and why things work. And the scientific method is fundamental to science. That's what science is all about. Science is asking questions, observing, making an educated guess, which is a hypothesis. When you make an educated guess, that's what you use kind of your best judgment based on things that you've seen happen on a regular basis. Then you say, oh, that could possibly happen. For example, I'm sure you've probably seen someone jump inside a pool, right? Your educated guess would be, oh, that person jumps inside a pool, they're going to get wet, right? That's a hypothesis. And then you have to test that by maybe pushing that person into a pool and then seeing what happens, right? Or maybe jumping into the pool yourself. That becomes your test. And so an educated guess is just using your best judgment based on what you've already seen before and had experience. And then you go down the testing route to see if that educated guess is actually correct.
Wow, that was so awesome. Maynard is so full of cool information. Now, we are moving on to our experiment. Now, here is our smart guess, our hypothesis. Now, we guess, then we test, and we check the result. Now, I think that we are gonna do a sink or float with you guys. Here's our water.
We did the sink or float.
This is true, we did do it before, but we're gonna do a new one again. Now, here, I've got a lemon. Let's drop this in the water and see what happens. I think the lemon is gonna float. That is my hypothesis.
Maybe it's gonna sink.
Let's test it. It floats. Oh, yeah. Now, Nee, what do you have?
I have a rock.
Now, what do you think is gonna happen when you drop that rock into the water?
100% gonna sink.
Drop it in. It's right, it sank. Now, next we have a plastic bottle that is empty and the cap is on top.
Shall we drop it?
You think it's gonna float? Our hypothesis is that it's gonna float. It did, it floated.
And I have a coin.
Here comes a coin. Okay, now what do you think is gonna happen?
I think it's gonna sink.
Let's take a look. That's our hypothesis.
3, 2, skip a 2.
There we go, it sank. Now, this one's a hard one. This is a leaf. I don't know if it's gonna sink or float, but it's very light and it's very wide. So what do you think is gonna happen?
It's gonna float.
Let's try it. Nee, your hypothesis was correct. Now, we guess, which is our hypothesis, and then we test and we check the results. Now, let's go to our next destination. Thanks, Anna! Wow, we are in the German Black Forest, and we are here with a scientist named Luca. And we're gonna do a new experiment. This one, we are gonna be mixing baking soda and vinegar, and nothing's gonna happen. Hang on.
For doing it, nothing happens. Then what's the purpose of doing it?
Well, we can test to see what happens, but actually something will happen. That's part of our hypothesis. Now, let's see what happens. But first of all, let's call Maynard and find out more about the scientific method.
Yeah. Why do scientists experiment instead of guessing?
Why do scientists experiment instead of just guessing? Great question. Let's see what Maynard says.
Ooh, that's another good one. Why do scientists do experiments instead of just guessing? Well, that's because we want to know scientifically if this can actually happen on a repeated basis, right? When you make an educated guess, that might work for one condition, right? But there may be another condition where you do that same test and a different thing happens, right? And so you want to do multiple different experiments. You want to do multiple different tests in order to help prove your hypothesis. And so a lot of times you'll hear about a controlled experiment where certain conditions are kind of remain the same. And then you'll learn about options where you can have variations where things can change. And you need to have these wide range of different experiments so that you can see if the same thing happens in every single condition. And so you want to do multiple tests so you see if there are any changes or see if something else happens, so that it better now give you a better understanding of whether your educated guess that you made was correct.
Oh, so we experiment to see what's actually gonna happen. If we guess, we don't really know, but we wanna find out the truth. Now let's see what happens. First of all, we're gonna mix in some vinegar and pour some baking soda on top, and here it goes. Boom! Boom! Wow, it's like a volcano. That's awesome. Let's go to our next destination and see what happens next, shall we?
To the India.
Whoa! Okay, that's cool. Nee is loving dance and she studies dance from all over the world. And we are in Bangalore, India with a very cool scientist named
Priya.
Yeah.
Now, Priya is studying computer science at university, and she actually is what we call a data scientist. So she takes all of this data and she makes it make sense. But we're gonna learn a little bit more about data science. But first of all, let's call Maynard and find out more about the scientific method.
How do scientists understand results of their test?
How do scientists understand the results of their test?
That's another great one. That comes hand in hand with doing the experiment. So as you're doing the experiments, you're analyzing, right? You're writing down numbers. You're writing down what you saw happen. You're making further observations. And all these things give you what we call data. Data is basically just information that helps you understand what you're seeing. And so now we have all of this data based on all the experiments that we made. And that data now gives us the ability to now make a final conclusion. gives us ability to now have a result and see why all this happened. And so you utilize that data, and that data is what you compile to get your results. And that results will ultimately give you what the correct answer, or maybe the educated guess that you made helps you know if that was right, or maybe help you know whether those guesses that you made led to proper results. And so that all those things kind of go hand in hand. Collecting the data is very, very important. You'll hear about scientists doing research trips and going on research projects. It might be in the rainforest, it might be out at sea, and we do these to collect data so that we can eventually come back to our lab or come back to wherever we're at and then be able to prove by all this data whether our educated guess was correct. And those data help us in those results as well.
Well, Priya, we have some results from our test. Can you help us understand it? So, when we tested our data, first of all, we have to check different things that we tested and then what happened. We tested the lemon, and did it sink or float?
Float.
It floated. It bobbed on top of the water. Now, what about the rock?
Sink.
The rock sank. It went straight to the bottom. How about the plastic bottle?
It float.
It floated. Now, it stayed on the surface. How about the coin?
It sank.
It sank. And finally, the leaf?
It float.
It floated. And that is our data because we did sink or float.
Sink, float.
Float. Now, Priya, thank you for helping us understand all that great data. Now, on to our next destination. Whoa! Hang on. This is our next scientist, and his name is Diego, and we are here in Mexico. Now, Diego is our scientist that's going to help us understand some cool stuff. But hang on, it has a camera. What are we supposed to do here? What's the last step of the scientific method?
I don't know.
I know, but I think we need to call Maynard first.
How do scientists share what they've learned?
Scientists share what they've learned. That's another good one. Scientists can share what they've learned in a lot of different ways. Me as a science communicator, I share a lot of what I learned through social media. So I do things on Instagram and TikTok and YouTube, making fun educational science videos to share some of the things that I know and share my knowledge and some of the things that I've been able to have a chance to work on, or maybe even share things from other scientists that I know or other research projects that are happening that I'm aware of now to the public, so they have an understanding of different things that are happening in the world of science. But a lot of scientists do research projects and they actually share what they've learned in what are called papers, right? Somebody might be a doctor, have a PhD, and you might write something in a journal. And when you get that paper published, that goes out to the wider scientific community of all these other people that have expertise in these different areas. And then you can have people review your paper, review what you published, and then give some feedback. Be like, oh, yes, I've seen this happen myself, or I've done this test, or maybe I did a test that was very, very similar and I saw similar results happen. And then they can kind of combine some of that information as well. So publishing your research findings in journals is one way. A lot of people and a lot of scientists write scientific papers. They might write for a blog, they might write for a journal, they might write for a newspaper as well too, to share some of the information that they learned. So all these are outlets and all these are forms of media where scientists can be able to share their findings and share everything that they've learned doing their research.
That's right. Once you do a scientific experiment, one of the most important things is to share your data, to share your information. And we need to make a quick video to share ours. That's all you, kiddo.
Hello everyone, today we are going to tell you about our experiment. We did sink or float. First of all, we tested a lemon and it floated on the water, like boom, 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 boom. Next we tested a rock, it sank.
Drop straight to the bottom.
And then we tested a plastic bottle and it floated.
It floated because it was filled with air. After that, we tested a coin.
The coin and it sank.
And finally, we tested a
leaf, which floated because it's very thin.
And we want to share this information with you. That was our next step. And that was all about sharing our experiments. And we had a cool background with a big rubber duck that floats. Finally, to our last destination. Whoa! Hang on. We're in Boston in the USA.
So cold.
It is quite cold here, but luckily it's the summertime, so we're okay.
Yeah.
But in Boston, there are a bunch of great universities.
Wow.
One of the big ones is MIT. There's also Harvard, some great schools here. But let's talk to Maynard because I don't see any scientists here right now. Let's ask him what's next.
Can anyone be a scientist?
Can anyone be a scientist? Absolutely. That is one of my phrases that I have on my platform is you are a scientist. It doesn't matter how old you are, how young you are, where you're from, your background, where your education level. Everybody is a scientist because science is basically just asking questions and wanting to know how the world works. And we make scientific discoveries all the time. When you wake up and you decide what you want to eat, if you go and work out, if you go and run around, you play, you see a light bulb go off, you see something fall and break, you're making observations. These are all parts of the scientific method. You're asking questions, you're conducting tests in real life. You're analyzing and compiling data based on things that you see visually or things that you work with. When you stick your hand in the mud and your hands get dirty or feel slimy or oily, these are observations that give you data to be able to understand how the world works. And so we are all scientists, and you can be a scientist just by going outside and observing, going outside and asking questions, picking up things. If you love exploring nature, going out and seeing wildlife, or going in your backyard and lifting up a rock and seeing what's living under the rock, you're able to make scientific observations in every single thing that you do. So yes, anybody can be a scientist, and you can be a scientist by simply just asking questions.
Hang on, Nee, we're here in Boston and you're the scientist. Anyone can be a scientist, and right now the scientist is you. One of the important things to realize is that we don't have to do science alone. And we can repurpose our old laser machine to turn it into the scientist assemble machine, but you have to press that button, Nee. Whoa, Nee, it's all of our scientific team that we met from around the world. Now together, we can solve some problems. And if we press this button again, I think it will fix all the problems. Shall we? It worked. It restored everything. But we only were able to do that with the power
Of help.
teamwork and science.
Then.
The end.
That was unexpected.
That was a bit surprising. Do you have any fun stories to tell?
No, I don't know.
One time when I was a small boy.
You farted.
That's not science. All right, we'll see you guys next time. Bye-bye.
Ailani's Little World. Subscribe for more educational content for you and your kids.